Well, each month, as I spend time preparing for the next month's Ranger Next segment, I spend quite a bit of time rooting around in the literature and looking at data related to the topics that we can bring you in hopefully an edutaining way. But I've never rooted around topics related to roots until now. Well, I'm spending some time on the campus of the University of Georgia with a new friend, Dr. Alex Brooks. So good to meet you, Alex.
Thanks for having me.
Oh, it's so good to be with you. And we're standing in your lab today, hanging out, and I want to make sure I get something correct. Your title is one that really intrigues me. You're an associate professor of computational plant science.
That's right.
Computational plant science, computers and plants. We're standing in a lab, we were looking at some roots here a second ago. What does that mean? Computational plant science, what do you do?
Basically, we just use computers to quantify the plant.
Okay.
That's what we do. And in that case, for the roots, we are actually measuring the whole architecture of the roots and how all these roots are organized and arranged within this root system. So this is the whole root system. There are many individual roots in it, and we measure like the angles, the number of roots, the density, how much biomass that is, all of these kind of things. We call that a trait.
That's a trait of this root. And this is another corn plant we're looking at here.
This is another
with a different appearance to it.
Right, and what you see is if they are in the ground like this, they, for example, have different rooting angles. If you just look here on the outer side, right?
Yeah. And why? Why look at this kind of stuff? I mean, I think about a cornfield, I think about the leaves, I can see how maybe healthy the plants are above ground. Yeah. But why are you looking at the roots?
Yeah, the root, think of it like the motor of the plant.
Okay.
Right? So normally we just see the top, the roof, right? But actually the motor down here takes up all the nutrients, all the water into the plant that makes it survive. And it needs that to make yield something that you eat.
And something that we need to be really efficient in doing too, maybe particularly in low water conditions and drought conditions. So you're studying that.
Right, you want to make that more efficient to get these nutrients and all the water out of the ground, especially now, climate change, everybody talks about it. Yeah, it gets warmer, there's less water in the ground, so we have to survive with less water as a plant.
And you are studying traits, characteristics of this corn plant that make it most efficient to uptake water and to survive.
For example, that's one of the applications that we do.
That's so cool. Well, here's what I want to do. I think it's so neat what you're doing here on campus. I want to show the folks at home how you're doing this, because there's this contraption that you introduced me to, and I want to show everybody at home how it works. I'm going to pretend like I know what I'm doing. This guy really knows what he's doing. We're going to look at that next and talk about how you're measuring these traits. So let's go there now. Well, Doc, what we're looking at here is a very sophisticated looking camera system that someone might think is some kind of a spaceship. Talk to me about what is this thing doing right now? We've got the root in the center. We've got these lights. What's happening?
So this contraption just moves around the root system, and every time it moves, it takes a lot of pictures. A lot of pictures from different kind of perspectives of the root system, and that way we can look inside the root system by analyzing how each perspective changes a little bit.
And I'm looking at that corn root right there, and it's really, really dense. You and I were talking earlier, and I kind of hold this is just a bean root.
That's a common bean, yeah, like a pinto bean.
Yeah, so this seems a lot less complicated than the corn root. So is it going to take longer for this guy to capture those images versus on this?
Yes, this takes much longer. This is pretty much the densest problem that we have. The corn is really, really complicated for us to measure. That was the challenge. This one you can do in 1 minute, in half a minute.
Interesting.
This one takes about 5 minutes.
And you're getting pictures inside, outside, all the interactions of those roots.
Right.
Your background is in math and computer science. Are you looking at some of the angles of the branching of the roots as you're doing this? Are you thinking in your mind about what the data might be saying about the special pieces of roots that are there?
Yeah, certainly. So we do think about, like, for example, what does the angle, does it benefit water uptake, for example? Or nutrient uptake? Like these measurements that we do characterize the root systems. Right? And then we have root system characteristics that are beneficial to uptake of certain elements from the soil. Yeah. What is in the soil, because that's what lets the plant grow.
Yeah, and we were looking earlier at a computer and looking at this picture in a 3D way, and you were able to move it around and look inside, and it was very sophisticated looking.
Sure, basically we just take all these images, we send them out to a very big computer, and then we get this digital twin in our computer.
And I like that phrase, digital twins. So let's take a look at these digital twins. I want to go into a computer lab with you. I want to look at these things on a computer screen and talk about what in the world is he doing with this data and what kind of questions he's answering. So let's go there now. Guys, we're looking at some of the images from the corn roots. What are we going to do with this from here?
So we basically took all of these images that we just sent to a cloud storage in Arizona. So in Arizona, there's the National Cyber Infrastructure, CYBERS. It's a really big project in the US.
Okay.
But we use this really national infrastructure to store all these images of thousands and thousands of corn roots.
Wow.
Also other roots like common bean. But we pick them up from there and send it to a supercomputer to get a 3D model out of it.
Okay.
A 3D model that is then this digital twin that we can look at and measure directly how many roots are within this root system, how dense is the whole root system, these kind of traits.
Now, that kind of information, as you're measuring those different kinds of roots, are you looking for special kinds of roots in that mass of corn roots that are telling you, hey, we need to replicate this genetically to make this better corn plant? Is that where you're going?
Yeah, precisely. Yeah.
Cool.
So what we, for example, do is, and actually we have to thank Su Jing for all these 4 years of work on this project, but we can look into all these substructures. For example, we just look at certain kind of roots. So there are different kind of roots, and like brace roots are there. They're above ground going into the ground, and we have crown roots that are just in the ground. Yeah. And we can take the whole root system out of each other, look at certain parts of it, and guess if we find relations between certain functions that they have. We don't know at the beginning.
And something I think is so special about this is you are taking this information and you are helping farmers to have better, more efficiently producing plants that are able to work better in low salinity conditions and drought conditions, all those kinds of things. And that's benefiting folks all over the country. This is, I think, a little known secret that's going on right here at the University of Georgia. Hey, we're rooting for them. You know what I mean? Guys, thank y'all so much for today. We appreciate you so much. And folks at home, y'all know what to do. While you're online checking out some of the old Ranger Nick YouTube videos, check out what's going on at the Farm Monitor Facebook page and the Ranger Nick Facebook page. And until next time, guys, as we always say, for the Farm Monitor, I'm Ranger Nick, reminding you that enthusiasm is contagious. So pass it on. Y'all, thanks so much for watching, and we'll be seeing you right back here again this time next month. See ya.